Hey guys, welcome back to Jyoti classes, and today we are going to start with the series of syllabus covering from today onwards. And from the recent update that the University of Mysore Vice Chancellor has given an update in the newspaper that at the month of December you are going to have your KSET exam. At the month of March the result will be announced. Okay, I think soon you are going to get notified regarding this information regarding this KSET. So let us start our preparation from today onwards, and roughly you have 2 months to cover your syllabus. And so in these 2 months let us cover all the concepts and problems. Those are asked, I mean problems means the questions which are asked in last year question paper, okay, previous year question paper along with the solution. Okay, so here I am starting with the mathematical physics, since it is the, like, it contains most of the concepts are involved in MMP. Nearly last year, that is, I mean in year 2021, they asked 9 questions from mathematical physics. 9 questions means you are roughly going to get 18 marks from MMP. Okay, so now let us start with MMP. In mathematical physics there are like different concepts, like what are the different things we should study. Those are, first thing is complex. We have to cover complex questions. Based on that, the complex few on the vectors and metrics and differential equation. In my last video I have mentioned what are the things we have to cover. So according to that we are going to start the classes or series from today onwards, and the first concept or the first chapter we are going to take is mathematical physics, that is from differential equations. What these type of differential equations are called as special type of differential equations. Like in our masters, this is mainly we are aware of different types of special differential equations. These are second order differential equations. Those are Hermite polynomials, Bessel polynomials, Laguerre, Legendre. Okay, these all are associated Legendre polynomial. These are the special type of differential equation. Why I am going to start with this special type of differential equation? Because in last year or in the previous year the questions are asked directly from this part. Okay, so without wasting much time, let us start. The first special type of differential equation is Hermite differential equation. The how can you recognize it is a differential Hermite differential equation? This is the equation of represent. If any equation is in this form, that is d square y by dx square minus 2 dy by dx into plus 2xy is equal to 0. This is the differential equation of Hermite polynomial. And in Hermite polynomial, when you solve this with the help of binomial expansion, you are going to get some equation, that is the solution y. You will get some values here, and in that value, when you put the corresponding n value from 0 to 1, 2, 3, so on up to, you are going to get these values. Like these are the first few order Hermite polynomials are. These are very important, I will say, because they have asked directly. Okay, in few of the last year question paper they have just directly asked the order of this Hermite polynomial, and simply if you are aware of these simple equations, with the help of practice you can get that. For n is equal to 0, what is the Hermite polynomial? For n is equal to 0, h of 0 is 1. For 2, 4x square minus 2. For h3, that is 8x cube minus 12x. For h4, I will suggest you, like, to the n is equal to 4, 0, 1, 2, 3, 4, try to remember these for 4n values, because normally they are going to ask up to these like these orders only. Okay, so then coming back, what is the generating function for Hermite polynomial, that is e to the power of 2zx minus z square is equal to summation of n is equal to from 0 to infinity hn of x by n factorial into z to the power of n. This is the generating functions. Based on the generating functions, question will be asked directly stating that with the help of the generating function derive the value for n is equal to 2 or 3. This is the type of question you are going to get with the help of generating functions, and this is the value. The orthonormal property for Hermite polynomial is integration from minus infinity to plus infinity e to the power of minus x square hn of x hm of x dx is equal to 2 to the power of n factorial into root of n into delta mn. This is delta mn is Kroneker's delta. Okay, I hope you are aware of that what is Kronecker delta. If not, I will be taking in while solving the questions. I will make you clear what is that. Okay, next. Now, what are the recurrence relations of Hermite polynomial? See, these recurrence relations are nothing but these are some of the derived values. With help of these recurrence relations, you are going to solve the questions very easily if you know these functions. Okay, for the given function, if it is similar to this type of relation, you can directly put the value and get the solution. Okay, just go on through all these differential equations, and next these are all about Hermite polynomial. Okay, now coming back to second form of special differential equation, and that is Laguerre differential equation. What is the differential equation for this Laguerre is x square d square y by dx square plus 1 minus x dy by dx plus n of y is equal to 0 is the differential equation. And for this, the first few orders of Laguerre differential equations are for L0, 1, 2, 3, and for L of n is equal to 0 is n factorial, for L of 0 is 1, for L of 1 is 1 minus x. Okay, correspondingly remaining. And the generating polynomial for Laguerre is e to the power of minus xt by 1 minus t is equal to 1 minus t summation of n is equal to 0 to infinity t to the power of n ln x by n factorial. Okay. Next, orthogonality property for Laguerre is from integration 0 to infinity e to the power of minus x ln of x lm of x delta x is equal to delta mn. Okay, next, second form is over. For this Laguerre, I did not mention the Rodrich's formula. What is the Rodrich's formula for Laguerre function is ln of x is equal to e to the power of x by n factorial dn to the x to the power of dn x to the power of n e to the power of minus x. Okay, here n will be taking the value from 0, 1, 2 and so on up to. Okay, just mention this Rodrich's formula for Laguerre function in your book. Okay, don't forget to write this because there is must and should questions on the Rodrich's formula directly. Okay, next. Now coming back to third type of differential equation, that is Bessel differential equation. The equation of Bessel is x square d square y by dx square plus x dy by dx plus x square minus n square y is equal to 0. Okay, next, and for the first kind of Bessel differential equation, that is j of 0 of x is, this is the solution form, and for j1 of x is equal to x by 2 minus x cube by 2 square dot form plus x to the power of 5 2 square into 4 square dot of 6. Okay, this is for the first kind, and the properties for Bessel differential equations are, then the properties of Bessel functions are these are for j of this is the fixed question. Okay, yeah, they'll just ask you the value of what is j half and what is the value for j of minus half. Okay, just remember this answer, and your like many of the times they have just mentioned find the value of the Bessel differential equation for j of minus half. Okay, that is root of 2 by pi x sin x for plus half, and root of j of minus half, that is root of 2 by pi x cos x. Okay, next the orthogonality condition for Bessel function is, that is integration from 0 to 1 x jn of x alpha into x dot jn of beta into x dx is equal to 0. Okay, and then the generating function for the Bessel equation is, that is e to the power of x by 2 that is z minus 1 by 2 is equal to summation of n is equal to minus infinity to plus infinity z to the power of n jn of x. Okay, and these are few of the recurrence relation. Just go through all these recurrence relations. Okay, next coming back to Legendre differential equation. Okay, for Legendre differential equation, the equation form is 1 minus x square d square y by dx square minus 2x dy by dx plus n into n plus of n into y is equal to 0. Okay, and next the Legendre polynomials for the few of the order n is equal to 0, 1, 2, 3. See, these are mentioned. For 0 it is 1, for p of 1 is x, and p of 2 is 1 by 2, 3x square minus 1, and p of 3 is 1 by 2, 5x cube minus 3x. Okay, next few of the properties for Legendre polynomials, and here for these properties remember this: for even function there should be even for even n, and there will be odd function for odd n. Okay, just remember this and get these properties of Legendre differential equation. And the generating functions for the Legendre polynomial is 1 minus 2x z plus z square to the power of minus half is equal to n is equal to 0, summation of n is equal to 0 to infinity z to the power of n into pn of x. Okay, next for orthonormal condition for this Legendre is, for orthonormal property of Legendre polynomial is integration from minus 1 to plus 1 pm of x plus pn of x dx is equal to 2 by 2n plus 1 delta mn, and these are the recurrent relations for Legendre polynomial. Okay, next now coming back to associated Legendre polynomial. This is type of, say that this associated Legendre polynomial is important one, because they have many a times there are questions based on this concept. So since in our MSc we tend to not study more about this, but still in KSET exam they have asked many times the questions based on this, and this is the equation form of associated Legendre polynomial. If you are able to remember this, it's okay, and if not, you can also remember this associated Legendre polynomial, that is d by dx 1 minus x square d by dx plm to the power of m into x plus l into l plus 1 minus m square 1 minus x square plm of x is equal to 0. Okay, next coming back to the Laguerre formula for associated Legendre polynomial, this is PL of x is equal to 1 by 2 to the power of L, L factorial, d to the power of L by x to the power of L, x square minus 1 the whole bracket to the power of L. Okay, next just remember this: for P of m to the power L into x, this is the formula, and for P of Lm of x is equal to 1 minus m to the power of PLM. These L and M are the values from 0, 1, 2, 3, so on up to. Depending upon these values, our function, that our polynomial, is going to change. The value for L and the value for M, whether they are positive or they are negative, if one is positive and the one is negative, what are the conditions? This is going to be like depending upon those. Okay. And next, coming back to orthogonality conditions for associated Legendre polynomial. That is, for orthogonality conditions, first of all, they are not mutually orthogonal to each other. If I say P1 1 and P2 2, they are orthonormal, actually they are not. But 1, if I can fix the m value, then the orthogonality condition I can write it down, and that is, this is the for the fixed m value, and for the fixed L value you are going to get this as the orthogonality condition. Okay. Now next, coming back to, if it is negative L or negative m value, what is the PL to the power of minus m? The value will be reduced to minus 1 to the power of m, 1 minus m factorial by L plus m factorial PL of m. Okay, if it is the mod of m that is greater than L, then PLM is 0. Directly remember that the function becomes 0. Okay, for the negative L value, PL minus 1 to the power of m for the corresponding L value which they are asking. To check whether it is positive, whether the function is positive or negative, we have to put in this formula and check out whether which type of associated polynomial Legendre polynomial they have given to us. Okay. And next, coming back to few of the associated Legendre function. Okay. In this, in year 2021, the question was asked directly from this, with if you were aware of these few associated polynomials, they last time they have asked this value. This value they have asked in last year. What is the associated Legendre function for P2 2? Okay, and that is 3 into 1 minus x square. If you are aware of these simple things, then you could have done this question correctly. Okay, so this much for associated Legendre functions, and these are few of the recurrence formulas. Okay, so let's end this all here. I will suggest you to that make a note of these all things. Okay, make a note of these all things and try to revise every day before like jumping into the problems. Okay, thank you.